Assalamualaikum. Dengar tak suara saya?
Waalaikumsalam, dengar.
Macam mana macam bergema macam. Saya nak kena off. Macam testing. Lama dengar saya masih dengar dekat. Sekejap Dr. Basri ada ni tak setting untuk adjust tak? Tapi student clear kan dia? Suara ke ada bergema?
Bergema.
Oh, bergema kan? Sekejap Sekarang bergema lagi tak? Sama juga. Sekejap. Mana saya nak adjust ni? Masih bergema Bergema lagi tak? Oh, masih bergema. Macam mana nak setting? Biasa okey je. Okey, sekejap. Dr. Basri suruh live punya laptop.
Okay, dengar tak kat sini? Boleh? Ini dah tak bergema Tak apa, you just open your mic je kalau ni. Masih bergema lagi tak?
Tak.
Tak? Okay. So saya tak boleh sambung ke laptop lah. Okay, kejap. Alright, so saya share screen balik. Okay, boleh nampak ke share screen sekarang?
Nampak.
Nampak. Okay, thank you Farah Ain So dia respond. Alright, so everyone can see the share screen, right? Okay ke yang lain? Sebab saya tak boleh buka laptop, jadi saya tak nampak every single comment pun saya tak nampak lah sekarang. So kalau ada apa-apa, just open your mic lah, okay? Alright, so for today's session on sharing on discrete probability distribution, so saya dapat info daripada Dr. Basri, you punya paper untuk subjek ni on 5 hari bulan 2, betul ke?
Betul.
Betul. Okay. Just open your mic lah sebab saya tak boleh buka you punya chat ke apa sekarang. Alright, so just nak tahu, you all dah study ke, dah buat revision ke untuk subjek ni before final? Dah ke belum?
Dah.
Oh dah, so boleh sama-sama buat latihan lah kejap lagi ni kan? Ini bukan macam lecture ni more kepada kita buat revision on latihan lah. Okay, sebab you pun dah habis syllabus kan? So just waiting for the final exam only. Alright, so we try directly go to the subtopic lah, okay? So for discrete, what do you understand by discrete? The word discrete. Apa maksud discrete kat sini? Anyone? Apa maksud discrete? Apa beza discrete dan continuous? Student statistik ni semua ni. What is the difference between discrete and continuous? Kita ada dua kan, discrete probability and continuous probability kan?
Betul.
Okay, so apa beza dia? What is the difference? Kalau discrete macam mana? Kalau continuous macam mana?
Kalau discrete dia boleh kira.
Okay, ada dia satu-satu lah kan? Kalau continuous macam mana?
Dia sampai infinity.
Okay, kalau continuous maksudnya you akan ada interval, betul tak?
Betul.
Ada range kan? Okay, so tu adalah the main difference between discrete dengan continuous. Alright, so hari ni kita akan cover the first one is on discrete random variables and probability distribution. Okay, the second one mean and variance, the third one binomial, and the last one Poisson distribution. Okay, so untuk formula for your subject, is it will be given or not in the final exam? Because for the binomial, Poisson, and mean and variance, you will have the formula, right? So is it that formula will be given or not?
No.
Okay, no, because you are maths or statistics students. Okay, because in UMPSA, I'm teaching the other course lah, which is engineering students. So for the engineering students, we will give the formula lah because they are not under maths and statistics program, but you are in maths and statistics program, so you should remember lah all the formula for this. For example, binomial, Poisson, okay? Alright, so we go the first one, okay, definition. Okay, so like I asked you before, what is the difference discrete and continuous? So you already understand lah what is the difference between discrete and continuous. Okay, discrete means that you can calculate. Okay, you can count manually lah 1, 2, 3, 4, 5. Okay, compared to continuous, you will have the interval or range. Okay, for certain values. Okay, that's the main difference between discrete and continuous. Alright. Okay, so we go to this example. Okay, so this is example of table and graph. Okay, so we have a number of source rented. Okay, we have 0, 1, 2 and the probability for each of the source rented. Okay, so from this from the table of distribution, you can convert to the graph. Okay, so you will have the graph here. Okay, for 0, you will have the probability is 0.5. Okay. Okay, and then for source rented 1, okay, so the probability is 0.4, 0.33. So means that we can visualize the distribution and probability in this graph lah. Okay, from the table of distribution, you can convert to the graph to visualize the probability. Okay, so that the example lah, okay, for the introduction to the probability, discrete probability. Okay, so we go to the first example here. Okay, so this is example of a toss a coin. Okay, this is the basic example lah, okay, in the statistic. Okay, so let's say you toss a coin 2 times. Okay. Sorry, saya pun tak berapa sihat sangat. Okay. Alright, so when you toss a coin 2 times, okay, sorry ya. Alright. So when you toss a coin 2 times, what happened? Okay, for the first toss, okay, you will have what? Okay, when you toss a coin, you will have what? Head and tail, right? Okay, so you will have head and tail. This is the first, okay, first toss. Okay, but the question asks you for the second toss. Okay, so means that you will have another one, second toss here. Okay, second toss. Okay, another one, head and tail, and then head and tail. Okay, so based on this one, okay, you will have this sample space. Okay, so this is your sample space based on this, what we call this one, tree diagram. Saya lupa dah, apa nama dia ni? You panggil apa? Yang brush ni? Tree diagram kan? Okay, kalau the first one will become H kan? Okay, the second one become HT. This one TH. Okay, this one TT. Okay, so this is your total sample space. We call it as the total sample space. Okay, so and then, okay, so now they assume that for X now, X refer to the, represent the number of H, okay, the number of head in the, in an outcome or in your sample space. Okay, for example, the first one, if X equal to 0 means that your H equal to 0. Okay, what is the probability of H equal to 0 in your sample space? There is no H in your sample space. What is the probability of X equal to 0? Anyone? What is the probability of X equal to 0? X now refer to the number of head. So means that when X equal to 0, your number of head equal to 0. Which one you have the number of head equal to 0? Which one? in your sample space?
TT.
Okay, TT. Okay, ada lagi tak? Only TT kan? Okay, if let's say only TT, so what is the probability?
1/4.
Okay, 1/4. So, understand? So, means that when your x equal to 0, so here x refer to the head, number of head. Okay, so we have 1/4. Okay, what about h equals to 1? Okay, what is the probability of h equals to 1?
1/2.
Okay, so means that you will have 1, 2, right? So, 2/4 or equals to 1/2. Okay, the last one, h equals to 2.
1/4.
Okay, 1/4. Okay, understand lah this part, the basic one? Okay, so let's move to the other part. Okay, so example 1.2. Okay, so we have this one, 5 out of 20 bulbs in a box are defect. So means that now your case are defect. Okay, 5/20 adalah defect. Okay, so and then Chong choose 3 bulbs from the bulbs randomly. Okay, if x is a random variable which represent the number of defect. Okay, so now your x is the number of defect. Okay, find the probability distribution for x and sketch the graph. Okay, so now we have probability of defect, okay, equals to 5/20. Okay, this is our probability of defect. Okay, but now Chong choose 3 bulbs from the bulbs randomly. Okay, so means that, okay, so Px equals to 3. Okay, we can use the combination here. Okay, so means that from 5 defect, okay, Chong choose 3. Okay, alright, so the left of the non-defect is 15C0. Okay, over the total one is 20C3. Okay, so this is the previous, but this one I think you already learned, right? Okay, for the combination. Okay, so what do you get the answer for this one? Anyone can calculate for this one? Ada tak sesiapa boleh tolong kira berapa dapat? Because kita sekarang buat revision lah. Okay, so untuk preparation you punya final. Anyone can calculate this one? Just open your mic, okay?
1/114.
Okay, so if let's say you convert to decimal, what you get? 0.
8.7 0.00877.
Okay, 0.009. Aku 0.009 lah, boleh kan? Okay, so this one, for x equals to 3, you have 0.009 here. Okay, so now we calculate for p x equals to 2. Okay, which is 5C2 times 15C1, okay, over 20C3. Okay, and then we have Px equals to 1. Okay, and then we have Px equal to 0. Okay. Alright, so this one I just give the answer lah, okay. Px equals to 2 equals to 0.132. This one, 5C1 times 15C2 over 20C3, okay, which is 0.461. Okay, the last one, 5C0 times 15C3 over 20C3. So you will have 0.399. Okay, so this one we just put into this table. Okay, because the question asks you to sketch the graph. Okay, so before you can sketch the graph, you need to have the distribution table first. Okay, so for Px equal to 0 is 0.399. And then for x equals to 1 is 0.461. X equals to 2 is 0.132. Okay, so when you already have the distribution table, so you can sketch the graph. Okay, what is the largest one here? The largest value is for x equals to 1. I think you can draw by yourself, alright? Okay, the table here. Okay, you have this one, the largest value, right? So means that you can put 0.5 here. Okay, the smallest value is 0.009. Okay, maybe you can start 0.1 here. So means that 0.009 will be here lah. Okay. So maybe you can draw a nice graph lah. Okay, compared to mine. Okay, for 2 is 0.132. Okay, this is example lah. For 1 is 0.461. And then this one, 0 is 0.399. Okay, means that what I want to deliver here means that when you want to sketch a graph, you need to have the distribution table. Before you can have the distribution table, you need to calculate what is the probability for each of x. Okay, any question for this one? Ada tak soalan untuk yang ni? Let's say you have any question, then directly ask lah. Just open your mic. Okay ke?
Okay.
Okay, so kalau okay, kita boleh proceed Alright, so next we go to the mean and variance. Okay, so mean and variance, I think all of you already familiar with the mean and variance, right? Okay, so this is a mean and variance for discrete, okay, for discrete random variable. Okay, so you have mean, okay, this is your mean. Okay, means that you need to multiply, okay, some x with the probability of x. Okay, so that's your mean. Okay, and then your variance is, okay, your variance you need to multiply x square with the probability of x. Okay, and then you need to minus with the value of mean square. Okay, and then the standard deviation is the square root of the variance. Okay, sikit tak apa, kita tengok example Ingat lagi tak ni? You dah belajar kan? Dah belajar kan? Dah
Ingat.
Okay, so alright, so we go to this example. Okay, so you have 5 ball here. Okay, 5 ball. Okay, number 0, 2, 4, 6. Okay, and 8. Right? Are placed in a big bag. Okay, after the balls are mixed, okay, one ball is selected. Okay, one ball is selected. Alright, and then its number is noted. Okay, and then it replaced. Okay, so this is the keyword you need to understand lah. Okay, what happened when it replaced? What happened if didn't replace? Okay, in the probability. Okay, so if this experiment is repeated many times, find the variance and standard deviation. Okay, find the variance and standard deviation of the number on the balls. Okay, so before that, we can draw a distribution table first lah. Okay. Sorry. Okay, for example, I have how many columns? 1, 2, 3, 4, 5, 6. Sekejap saya lukis je lah ni. Okay, so you have a number of ball 0, 2. Okay, and then 4. Okay, and then 6. Okay, and then the last one is 8. Okay, so means that now, okay, here is, okay, this is your X. Okay, your X which is the ball number. Okay, which is you have 0, 2, 4, 6, and 8. Okay, this is your ball number. Okay, this is your probability of X. Okay, so here, what is the probability of X equal to 0? Anyone here? Okay, because they say that one ball is selected, its number is noted, and then it replaced. So, for example, he take the ball number 0. What is the probability of they take the ball number 0? Anyone?
1/5.
Okay, betul. 1/5. So, is it same for all the ball number here? For 2, 4, 6, 8, is it the probability is 1/5? Sebab dia kata
Yes.
dia replace. Okay, so yes. So, this one should be same. Okay, 1/5 for all ball number. Okay, so you have 1/5 for each of the number on ball. Okay, so now we want to calculate for the mean. Okay, so for the mean, okay, mean equals to mu, right? Okay, mu equals to mean. Okay, set lah notation for mean is mu. Alright, so equals to EX. Okay, so for the mean, you need to multiply X with the probability of X. So means that 0 times 1/5, and then you need to sum up, okay, until the last ball number. Okay, and then plus 2 times 1/5 plus 4 times 1/5 plus 6 times 1/5 plus 8 times 1/5. Okay, so anyone can calculate for me for this mu, mean? What you get for the mu or mean for this data?
Four.
Okay, 4, correct. Okay, so this is how you can find the mean, okay, for this grade. Okay, so after you find the mean, now we want to find for the variance. Okay, so the notation for variance is sigma square. Okay, variance equals to, you need to take x square multiply with the probability. So means that 0 square, okay, times with 1/5. Okay. Then you have the bracket here. Okay, plus 2 square times with 1/5. Okay, plus 4 square times 1/5 plus 6 square times 1/5 and then plus x square times 1/5. Okay, so you close bracket, but for the variance we need to minus with the mean square, mu square. which is 4 square. Okay, because you already obtained the answer for the mu is 4. Okay, at above here. Alright, so for this one, you will have 24 minus 16. Okay, if you calculate, you will have 24 minus 16, so the answer is 8 for the variance. Okay, so remember, for the variance, you need to put the x and then square, and then times with its probability, and then sum up all the probability. But the last one, you need to minus with the mu square, or mean square lah. Okay. Alright, so let's say you already obtained the answer for the variance. Okay, now we go to the last part, which is standard deviation. Okay, standard deviation, you can just square root the value of variance. Okay, so you will have square root of 8, so you will have 2.8284. Okay, so this is the concept of the mean and variance for the discrete probability function. Okay ke? Ada yang tak faham tak untuk yang ni? Mean and variance. Okay tak?
Faham.
Faham
Okay, faham.
Okay, kalau keluar exam boleh jawab dah kan? Jangan salah formula sebab you all tak diberi formula kan untuk math student. Okay, so make sure you use the correct formula lah. Okay, don't forget to minus with the mu squared for the variance. Okay, so next we try to go on revision on binomial. Okay, so what you understand by binomial? Okay, let's say I ask you the difference between binomial and Poisson. What is the difference between binomial and Poisson? What comes first in your mind? Okay, for the binomial. Apa beza binomial dengan Poisson? Ada tak siapa-siapa yang ada idea? Tak ada? Tak ada ke? Anyone? Alright, so saya just tak ada apa, saya just give tips lah. Okay, untuk binomial, normally you will have the success rate. Okay, you will have the success rate. Okay, compared to Poisson, kita tak ada success rate. Okay, so normally binomial you will have the success rate. Okay, so probabilities, binomial sebenarnya you nak cari probability of success. Okay, contohnya probability bila you toss a coin kan. Okay, probability you nak dapat head. Okay, itu dikira probability success lah. Okay, maksudnya apa-apa yang berkaitan dengan success rate, okay, kadar kepada success, itu adalah binomial. Okay. Okay, contohnya, you toss a coin. Okay, baby is born. Okay. Baby is born ada apa? Ada choice apa? Ada choice boy or girl kan? Okay, ataupun true false question. Okay. Produk ataupun dan lain-lain lah. Okay. So, dekat binomial, each trial must have outcome classified into 2 relevant category only. Okay, success and failure. Okay, so bila sukses, dia dikategorikan sebagai P. Okay, P adalah sukses. Okay, Q adalah failure kalau dalam binomial. Right? Okay, kita tengok example. Okay, this is notation, okay, for the binomial. Okay, if let's say probability of success, okay, we call it as the, denoted as the P. Okay, small p. Okay. And then for the probability of failure, okay, which is 1 minus P or Q. Okay, so N is the number of trial. Okay, X ni adalah sukses, berapa banyak yang nak cari sukses dalam set trial tu. Okay. Alright, so kita punya binomial distribution adalah X binomial n dengan p. Okay, this is your binomial distribution. Okay. Alright, so this is the binomial probability formula. Okay, so saya nak tanya sekarang, semua orang dah mampu ingat ke ini? Ini tak diberi juga kan dalam formula kan? Tak ada kan? Ke ada? Ada tak?
No formula.
Okay, no formula. So you need to remember all the formula, right? Okay,
Yes.
so this one, is it you already memorized or not for this one? Dah ingat ke?
Memorize.
Alright, so this is the binomial probability formula. Okay, so this one you only can use if, let's say, you have the equal sign. Okay, only equal sign you can use this formula. Alright. Okay, so, okay, mean and variance, okay, for the binomial of x, okay, mean is, okay, mu equals to np, okay, and then variance equals to npq. Okay, normally I will write down on npq lah. Okay, or is it you familiar with this one? Which one? np1 minus p or npq?
NPQ.
Alright, so we use npq lah. Okay, so we know that q is 1 minus p. Okay, 1 minus p is the 1 minus probability of success. Okay, p is probability of success. Alright, so we try to go to this example. Okay, example 1.4. Okay. Right, so we read this one. A survey found that, okay, 30% of teenage consumer receive their spending money from part-time jobs. Okay. Okay, if 5 teenagers are selected at random, find the probability that at least 3 of them will be part-time jobs. Okay, so how to solve this one? Okay, so you found that 30% teenage consumer receive their spending money from part-time jobs. Okay, if 5 teenagers are selected, okay, 5 teenagers are selected at random, okay, find the probability that at least 3 of them will have a part-time jobs. So how to solve this one? Okay, so now what is your P now?
P is 0.3.
Okay,
N
P is
equal to
0.3. Okay, and then?
N equal to 5.
Okay, N equals to 5. Okay, so we already have N and P, right? So we can try to write down the binomial distribution first. Okay, X distribute binomial with 5 and 0.3. Okay, so now question asks you find the probability that at least 3. Okay, how to write down for the probability of at least 3?
Px more than equal 3.
Okay, great. Px more or equal than 3. Okay, this is the notation for at least 3. Okay. Right, so how to solve? Okay, so this one we can figure out like this lah. Okay. Px equals to 3. Okay, plus Px equals to 4. Okay, plus Px equals to 5. Okay, so because we have n, our n now is 5. So we can reach until the maximum number of n, which is 5. Okay, starting with Px equals to 3. Okay, and then end with Px equal to 5. Okay, so for this one, we can use the combination lah. Okay, 5 C3. Okay, 0.3 okay, to the power of 3. Okay, so if let's say okay, alright, so and then this one 0.7 to the power of 2, okay, plus 5c 4, 0.3 to the power of 4, okay, times 0.7 to the power of 1, okay, plus 5c 5, 0.3 to the power of 5, and then 0.7 to the power of 0. Alright, so let's say we calculate this one, so you will have the final answer is 0.163. Oops, sorry. Okay, 1631. Okay, this is how you can solve lah. Okay, I think the most important part for this question is how, okay, this part. Okay, if let's say this part settle, then you have no issue lah. Okay, you need to settle for that one lah, the first part. Okay, and then also this part. Okay, so normally if you settle the first and the second part, so for the calculation, normally no issue lah. Alright. Okay ke yang ni? Boleh? Any question for this one? Ada soalan tak untuk ini?
Tiada.
Tiada. Okay, so this is on binomial. Okay. So, binomial, you must remember that it's relate with the probability of success lah. Okay, you will have the success rate and failure rate. Okay, sorry, the success, probability of success and probability of failure. Alright, so next we go to example of this one. Okay, using symmetry properties to read binomial table. Okay. Alright, so this is the special case lah. Okay. Bila masa kita perlu guna prinsipal ni bila okay, sebabnya you punya binomial distribution hanyalah okay, only up to P equals to 0.5 only dekat table. Okay. So let's say your P value is more than 0.5. Okay, let's say your P value is more than 0.5, you need to use this symmetry properties. Okay, untuk baca dekat binomial table. Kalau tak, you tak boleh baca nilai sebabnya maksimum nilai P pada binomial statistical table adalah 0.5. Okay, tapi let's say you have P value is more than 0.5. Okay, you need to use this symmetry property. Okay, alright, so we look at this example. Okay, example 1.5. Okay, so if we write down here, okay, given that n equals to 9, okay, and then P equals to 0.7. Okay. Alright, so when we write down the distribution, binomial distribution, we will have X distribute a binomial with, okay, n is 9, P is 0.7. Okay, ini kalau kita tulis distribution lah, binomial distribution. So, means that now, your P, okay, P already greater than 0.5. Okay, which means that you cannot read directly from the statistical table. So, for this case, we need to use the symmetry property. Okay, so now we try to look at for question A. Okay, maybe the rest you can try your own lah. Okay, later. Okay, we try to do for A. Okay, P X less or equal than 4. Okay. Macam mana bagi besar ni? Okay. Okay. Alright, so when you see this sign which is less or equal, okay, we refer back to the symmetry properties here. Okay, this is the less or equal sign. Okay, so for less or equal sign, we need to use this 1. Okay. Alright, sebelum tu kita tulis dulu kat sini Kita punya N adalah 9. Okay. Kita punya P adalah 0.7. Okay, so this one sebabkan dia less or equal, so kita write down dulu dia punya symmetry properties. Okay, which is P x greater or equal N minus K. Okay. Okay, and then X binomial, X distribute binomial. Okay, N 1 minus P. Okay, so kita kena guna yang ni untuk case yang less or equal. Okay, so we do step by step lah. Color apa jauh lah. Alright. So for this one now. Okay, so kita ada P X greater or equal, okay, N minus K. Now our K equals to 4. Okay, let's say N minus K, what is the value now? Our N is equals to 9. So N minus K become?
5.
Okay, 5. So we have 5 here. Okay, and then X distribute binomial. Okay, N is 9. Okay, 1 minus P. Our P is 0.7. If let's say 1 minus P become?
0.3.
Okay, so we have 0.3 here. Okay, so this one. Alright, so now we have X greater or equal than 5. Okay, so this one we can calculate. Okay, if let's say we want to use the statistical table only read for what sign? Less or equal or greater or equal? From the statistical table? Let's say this one you want to find the value from the statistical table. You need to convert to the less or equal sign, right? Okay, so for Px greater or equal to 5, so actually equals to 1 minus P x less or equal to 4. Okay, so now the probability becomes 0.3. Okay, so because you want to find for x greater or equal to 5, actually 1 minus Px less or equal to 4. So you will have the same answer lah. Alright, so from your table, okay, you need to find this value, okay, x less or equal 4. Okay, so I think I already have the table here. Okay, so the first one, we need to refer to the binomial distribution table. Okay, cumulative binomial distribution table. Okay, and then for n equals to 9. Okay, and then what is our P now? What is the P? This is your P, right? 0.3. Okay, so I just highlight lah. Okay, so this is your P, 0.3. Okay, n equals to 9. Okay, because for the binomial statistical table, it will read, okay, x, okay, less than x, okay, less or equal. Alright, so what is the value of x now? 4, right? Okay, so for 4, here. Okay, so what is the probability for this one? Okay,
0.9995.
0. Is it 0. This one, right? Is it? Betul tak? Ke saya salah tengok?
Yes.
Oh yeah.
Betul
Betul.
0.9012. Okay, so this one for x less. Okay, so we have 1 minus 0.9012. Okay, so become 0.0988. Okay, so this is your answer lah for question A. Okay, boleh ke? But I just show the for question A only lah, because for the rest you can refer. For example, this one equal, right? Okay, for B is equal. Okay, equal you need to refer the first one here. Okay. Okay, if let's say greater or equal, okay, greater or equal for C, right? Okay, for example, for C, you can refer the third one. Okay, the step are same lah, but refer to the formula lah for the symmetry properties. Okay, because the symmetry properties will depending on the sign. Okay, whether equal, less or equal, or greater or equal. Okay, alright, so this is you can read from the statistical table lah. Alright. Any question for this one? Ada tak soalan untuk ni? Sebelum kita proceed. Ada soalan tak? Tak ada?
No.
Okay, so kita proceed . Untuk baca statistical table tak ada isu . Semua orang dah okay kan? Boleh baca kan? Statistical table. Sebab you student maths kan? Student maths normally no issue lah. Alright? Okay, so like I said before, for the binomial, you will have the probability of success and probability of failure, right? Okay, now Poisson. What is Poisson? What is the difference between Poisson and binomial? Anyone can give your idea for Poisson? Okay, what is the probability distribution for Poisson? You will have X distribute Poisson with lambda, right? Okay, so this one you will have, okay, probability that applies to occurrence of some events that you have the interval. Okay, for example, time, volume, area. Okay, so you will have this interval. Okay, so let's look at the example for Poisson. Okay, so you will have the distribution is X distribute Poisson with lambda. Okay, so again, this is the formula you need to memorize for the Poisson. Okay, previous on the binomial. Okay, now this is for Poisson. Okay, this formula only can be used if let's say you have the equal sign. Okay, you cannot use for the less or equal or greater or equal. Okay, you need to convert to the equal sign first, then you can use this formula. Alright, so for the Poisson, okay, you will have the mean equals to lambda, okay, and then variance also equals to lambda. Okay, same. Okay, mean equals to lambda, and then variance also equals to lambda. Alright. Okay, so let's look at this example 1.6. Okay, customer arrive at a travel agency at a mean rate of 11. Okay, so you have a mean rate of 11 per hour here. Okay, assuming that the number of arrival per hour has a Poisson distribution. Okay, so now it has a Poisson distribution. Okay, determine the probability that more than 10 customer. Okay, more than 10 customer arrive in a given hour. Okay, so before that, we need to write down the Poisson distribution first. Okay, so means that you will have X distribute Poisson, okay, with lambda equals to 11. So means that now your lambda equals to, okay, lambda okay, lambda equals to 11. Okay, based on this distribution. Alright, so question mentioned, find the probability that more than 10 customers arrive in a given hour. Okay, so means that you need to find P X more than 10. Okay, because of more than 10 customer. Okay, so any idea how to find PX greater than 10? Ada tak idea? Macam mana? PX greater than 10? If let's say I want to use from the statistical table. Because we know that statistical table, you need to have the less or equal sign to have the value from the statistical table. So how to convert it now from this one? Anyone?
Px greater than equal 11.
If that one will include 11, right? Tapi betul juga kan? Okay, so the first choice is P X less or equal than 11. Any idea? Ada tak yang suggestion lain? Ada tak yang lain ke tak ada dah?
1 minus P X less than 9. Less or equal 9.
Less or equal 9. Kalau yang macam tu, dia akan masuk 10 sekali kan?
Yes. And
Tapi yang ni dia tak, kalau tanda macam ni dia tak termasuk 10, betul tak? Sebab greater than, dia tak ada greater or equal. Okay, so what is the correct one is it this one is the correct one? Kalau ikut logik. Betul tak yang ni? Kita nak cari PX lebih besar daripada 10.
No.
no.
Maksudnya no tu apa? No tu ada suggestion lain ke macam mana? Ada suggestion lain ke? Cuba fikir macam mana nak cari. Kita nak cari X lagi besar daripada 10 tapi tak termasuk 10. Okay, total probability ada berapa?
1.
Okay, 1. Okay, so maybe you can have 1 minus P X less or equal than 10. Okay, so bila you buat macam ni, you akan dapat nilai yang X lagi besar daripada 10 tapi tidak termasuk 10. Faham tak? Okay, so kalau kita guna yang ni, okay, dia akan dapat yang kurang daripada 11 termasuk 11. Okay, so now this is the correct one lah. Okay, 1 minus Px less or equal than 10. Okay, so now kita nak cari X less or equal than 10. If let's say you already have the less or equal sign, so you can use the statistical table. Okay, before that, check for the Poisson. Okay, and then your lambda. Alright, so lambda here is equal to 11. Okay, so find your lambda now, 11 here. Okay, and then we want to find X less or equal than 10. Okay, 10. You boleh nampak tak berapa nilai dia? Berapa nilai dia? .4599.
4599.
Okay, betul. 0.4599. So here we put 1 minus 0.4599. So you will have 0.5401. Okay, so this is example lah you can find. You can solve this type of question. Okay, boleh ke? Ada sikit je lagi kita nak habiskan. Ada 2 example je lagi. Can we continue ke ada soalan nak tanya untuk yang ni?
No.
Tak ada Okay, so we continue. Alright, so now we want to see the special case also. Okay, which is using the Poisson distribution as an approximation to the binomial distribution. Okay, bila masa kita boleh guna Poisson untuk approximate kepada binomial distribution. Okay, so bila masa kita punya ingat lagi masa kita punya binomial ada nilai n dengan p kan? Okay, so bila n greater than 50, and then p is less than 0.1. Okay. So bila case macam ni, bila you ada n greater than 50, and then p less than 0.1, you can approximate using a Poisson. Okay. Boleh guna tukar kepada Poisson. Okay, lambda kan. So, lambda here sama dengan NP kan. So, bila you dapatkan nilai baru, NP tu mestilah kurang daripada 5. Kalau let's say you dapat lebih daripada 5, mungkin ada something wrong lah dekat calculation. Okay, supposedly bila you approximate, you akan dapat NP tu less than 5. Okay, so kita tengok example Okay. So, now example 1.7. Alright, so this one, ada telur, packed into a boxes of 500. Okay. So, on average, 0.7% of the egg are found to be broken. Okay, so now for this case now, they consider the probability of success the broken egg. Okay. Alright, so find the probability that in a box of 500 egg, for the first one, exactly 3 are broken. So, means that this one they want to find Px equal to 3. Okay, so the second one is at least 2 are broken. So, means that kalau at least macam mana? Px, notation dia apa? Sign dia apa? Kalau at least
Greater than or equal.
Okay, greater or equal than 2. Alright, so now we just extract the information first. Okay, so our n equals to 500. Okay, so P is 0.007 because of this 0.7%. Okay, so if you notify here, n already greater than 50. Okay, P less than 0.1, right? Okay, P less than 0.1. Okay, so for this case, you can approximate to the binomial. Okay, can approximate to binomial. Binomial pula. Poisson, sorry. Okay, approximate to Poisson. Okay, with lambda. Okay, lambda here equals to NP. Okay, so NP here, N is 500, P is 0.007. So means that 500 times 0.007. So you will have 3.5. So now the new distribution is Poisson 3.5 because your lambda now becomes 3.5. Okay, so this is the first step you already approximate. Okay, because of the large value of n and small value of p. Alright, so we try to answer for question 1. Okay, so Px equals to 3. Okay, this one when equal, you can use the formula, right? Okay, which means that 3.5 to the power of 3, over 3 factorial e to the power of negative 3.5. Okay, so you will have 0.2. Tadi tag kalau pencil ni. Okay, 2158. Okay, so this is your answer lah for x equal to 3. Okay, so for the equal, okay, remember for the equal sign, directly use the formula. Okay, whether for binomial or Poisson, but this one for Poisson, right? So you need to refer to the Poisson formula. Okay, so and then next question 2. Okay, P x greater or equal than 2. Tadi tagline. Okay, so for x greater or equal than 2, macam mana? Kita nak convert dia, kita nak baca daripada statistical table ni. Kita kena tukar dia kepada yang ada less or equal sign. Okay, macam mana nak convert dia? Jadi berapa? Kita nak cari probability of x lebih besar ataupun sama dengan 2. So macam mana?
1 minus
1 minus P.
Px less than or equal to 1.
Betul. Okay. So kita cari macam ni lah. Okay. So means that nanti dia akan 1 tolak dengan probability of x less or equal than 1. Okay. So this one we can find from the statistical table. Alright. So now our lambda equals to what before? Lambda is 3.5. Okay, lambda kat sini 3.5. You punya x adalah 1. Okay, so berapa probability dia? 1 tolak berapa? Anyone?
0.1359.
Okay. 0.1359. Alright, so the answer is 0.8641. Okay, this is the probability of Px greater or equals than 2. For the case of kita approximatekan binomial kepada Poisson because of the large value of n and small value of p. Okay, so you kena consider lah, tengok dekat statement ayat dia tu apa nilai untuk n dengan p. Okay. Alright, any question for this one? We just left one example. Okay, before we end our session lah for this evening. Ada tak soalan untuk yang ni? Tak ada Hopefully clear Alright, so we go to the last one. Okay, before thank you. Okay, so this one, example 1.8. Okay, in a given city, 3%. Okay, so you have 3% here. Okay, 3% of all licensed driver will be involved in at least one accident. Okay, in any given year. Okay, determine the probability that among 150 licensed driver randomly chosen in this city. Okay, so for question 1, only 5 will be involved. Okay, if let's say only 5 will be involved, it means that Px equals to 5 lah. Okay, for question 2, at most 3. Kalau at most 3 jadi apa? Px
Less than equal to.
at most 3 dia akan jadi 3 jugalah. Sebab paling banyak pun 3. So you kena masukkan juga 3. Okay, kalau you masukkan x less or equal than 2, tak masuk 3. Okay, kalau nak masukkan dia kata at most 3, paling banyak pun 3. So 3 termasuk lah. So that's why we have x less or equal than 3. Okay. Alright, so now kita extract information yang ada. Alright, so we have P equals to 0.0, P equals to 0.03 kan? Okay, 03. Okay, so kita punya N adalah 150. Alright, and then, okay, so inilah kita punya value lah yang ada kan. Okay, so kalau kita tengok kat sini N greater than 50, P less than 0.1. Okay, so bila kita nak approximate kepada Poisson, okay, so we need to find lambda equals to NP. Okay, bila NP maksudnya 150 times with 0.03. Okay, so you will have 4.5 here. Okay, so kita sekarang masih berada di special case lah of the large of N and small value of P. Okay. Alright, so you punya distribution yang baru adalah, okay, 4.5. Okay, because lambda equals to 4.5. Okay. Alright, so we try to answer for question 1 and 2 here. Okay, for question 1, Px equals to 5. Okay, so this one, remember that for every question using equal sign, directly use the formula. So means that 4.5, okay, to the power of 5 over 5 factorial e to the power of negative 4.5. Okay, so this one you will have 0.1708. Okay, for the case of Px equal to 5. Okay, so we go to the next one. Okay, Px less or equal than 3. Okay, so macam mana nak cari kalau yang ni? Boleh cari directly daripada table tak ni? Boleh kan? Sebab ni dia dah direct less or equal kan? Okay, so now kita punya lambda adalah 4.5. Okay, so saya padam yang tadi. Okay, lambda kita adalah 4.5. Okay, K berapa? K adalah 3 kan? Okay, so K kita 3. So berapa probability dia?
3423.
Okay, so 0.3423. Okay, so inilah jawapan akhir untuk Px less or equal than 3. Okay, so actually we already comes to the end lah, last slide for this evening session. So any question before we end our session? Any question? Ada tak yang mana-mana tak faham? Ada ke? Ada tak? Just open your mic lah kalau ada part mana-mana yang tak clear ke. Tak ada Senyap je ni. Tak ada Okay, alright. So if let's say there is no question, then we'll say thank you lah to Dr. Basri for inviting me to share for this topic lah for today's session. Alright, so thank you everyone for joining this one, and then good luck for your final. Okay, next week.
Thank you,
Okay,
madam.
thank you.
Thank you, doctor.
Welcome.
Thank you,
madam.
Okay.
Thank you, madam.
Welcome.
Thank you, madam.
Okay, welcome.